So all along in this unit, we've been factoring. And we've seen lots and lots of different ways to factor. Okay. Um, Notice that there's some things I want you to see right quick. First of all, these are all the different ways that we've had to factor, but there's some key factors here. For example, if I have two terms, then after I look for the GCF, so the first thing I've got to do is look for the GCF. But after I take out the greatest common factor, I want to note: does it have two terms? Does it have three terms? Or does it have four terms? If it has two terms, then it's a good possibility that's a difference in squares. But I got to be careful, because unless there's a subtraction sign, then it's not a difference. And so if it does not have the subtraction sign, it's not a difference in squares. It may be prime. It may be that I can't factor it. And that's with two terms. Now, if there are three terms, we already know how to factor a trinomial. And we know that we've got to find the factors of the last number. Okay. And we want those two factors to add up to be the middle term. We've done that. It's after we find the greatest common factor. And we also know if it has four terms, that it's going to be factored by grouping. We've done a lot of that. There's one situation that we've not done. If it's a trinomial, now notice we've got the form written a little different here. It says ax squared plus bx plus c. What that means is if x squared has a coefficient of anything other than 1, it's a little trickier to factor. So let me show you how we're going to do that, okay? And we're going to simply do that by taking some notes. So again, what I'm saying here is if there is a number in front of x squared, see the number here, number in front of x squared, the way I've got to factor it's a little bit trickier because the combination of numbers gets to be quite large. And so the first thing I would tell you is that over the years, there's been lots of different ways to factor this sort of problem. Lots of ways. In fact, when I was in school, my least favorite method that they showed us was trial and error. And they said, go through and pick factors till you find a set where it's like working a problem 15 times. Okay. Then there were other ways that came about. You could convert this to a factor by grouping problem, but even that, I think, is not the easiest way to go about it. Then, when I was first teaching at Jeff County High School, I used a thing called the box method. And I really liked it because it worked really well. But the way I want to look at it and the way I want to show you today has a couple of different names. I think the name sounds kind of silly. Slide and divide is one thing it's called, or slip and slide, or again, I think the names are a little bit silly. But the actual way to factor it isn't, and it works every time, okay? So the first thing I want to look at is this problem. Now look at 6, 21, and 45. The first thing I've got to do is to determine what the GCF is, and if possible, factor that out. So I've got a 6, 21, and a 45, and I know that 21 won't divide by 6. Again, I always look at the smallest number there, the factor, and I'm thinking, okay, well, 2 times 6, so these obviously wouldn't divide by 2, but 3, 2 times 3 is 6. That's what I should have said. 2 times 3 is 6. So what about 3? Well, I know that 6 will divide by 3, and 21 will divide by 3. What about 45? Well, I may or may not remember or know if 45 will divide by 3. So if I don't know that, I've got to check it. Well, sure enough, it does. So I do have a GCF of 3 here. But I don't have a variable portion of the greatest common factor. X squared, X, and no variable. Okay, so that being the case, my GCF is 3. So my first step is to factor that out. And it'll be 2x squared, because 2 times 3 is 6, minus 7x. Okay, 7 times 3 is 21. Okay, minus 15. It's extremely important to factor out the GCF first. All right, still, though, after I factored out that GCF, I've got this pesky coefficient on x squared. That's the a part of ax squared plus bx plus c. So all the ABC represents, when you see it like that, is whatever number is the coefficient of x squared. In this case, the number that's in front of x squared. And the number in front of x and the number that's by itself. That's what ABC represents. We just show that in a generic form. So I got 2x squared minus 7x minus 15, and I need to factor that. Now, that's where the slide and divide part comes in. So this is where you're going to have to really focus in and pay attention to what I'm going to do. It's really quite simple. I'm going to take the 2, and this is where the slide part is. I'm going to multiply it times 15. Now, remember that I multiplied the 15 by 2. And I'm going to rewrite it. So here's what it looks like. It's going to be x squared, and when I slide it away from it. There's no coefficient now. Minus 7x, and 2 times 15 is 30. So it becomes now x squared minus 30. I've got to remember that I multiplied by 2. And of course, I can look back to the coefficient to remember that. All right, so everything looks pretty good so far. Now, what I want to do is list the factors of 30. Now, remember, I can use the TI-83 for that. I'm going to do it without a calculator because I can. And I know that it is the factors of negative 30. Can't leave that part out, okay? So I know it's a negative 1 times 30, a negative 2 times 15. I know it's a negative 3 times a positive 10. Notice I'm getting the negatives and positives correct. Negative 4, 30. Well, 30 divided by 4, no, it won't. Negative 5 times 6. And then notice the next one would be 6. So that's all the factors. The other side of that is a positive 1 times a negative 30, 2 times a negative 15, 3 times a negative 10, 5 times a negative 6, okay? So I've got all my factors listed. We did this yesterday. So when we did that chart, what I want to do is I want to know which of these factors had to be negative 7. Okay? Okay, so let's add them. Well, negative 1 and 30 is 29. It's not going to be that one. Negative 2 and 15, that's a positive 13, not that one. 7, and that's a positive 1, so not that. Again, I'm looking for a negative 7. So 1 and a negative 30 is negative 29, if I add those. 2 and a negative 15, that's a negative 13. Aha, check it out. 3 and a negative 10, when I add those, is negative 7. So bingo. That's what I'm looking for. 3 and a negative 10. All right, so here we go. To factor it then, all I have to do is use the 3 and the negative 10. Okay, now it's going to be plus 3 minus 10. Okay, hang on just a second though. That's not the factorization just quite yet, because remember, I multiplied to get here by negative 2. So to fix that, I can't just multiply without putting that back. So in my answer, I go, well, with whatever I multiplied, and I go back and I divide that term by that. Almost there with my factorization, okay? It's almost done. Check it out. This will be x minus 10 divided by 2 is 5. And then I don't want a fraction in there. 3 doesn't divide evenly. But if you go back to the first year, we said if we multiplied by 2, we could get rid of a fraction. Here's what I'm going to do. This 2, I'm going to multiply there. That'll be 2x plus 3. All I did was multiply the x by 2 and the 3 by 2, which I can do. And it'll be 2x plus 3. So that's my factorization. 3 times 2x plus 3 times x minus 5. All right, it might seem a bit complicated, but I'm going to tell you right up front, having factored a lot over the years, it's by far the easiest way to factor if you can get the hang of it. And you can only do that through practicing. You'll become a factoring wizard. You'll be able to do it without even thinking. Well, let's look at a second example. Negative 5x squared plus 8x plus 4. Now, 5, 8, and 4 won't divide by one number. That GCF there, then the first thing I've got to check is going to be 1. But notice I've got this leading negative. I don't like that. I can't factor with that. So my GCF here is going to be negative 1. So all I'm going to do is factor out a negative 1 and reverse the signs all the way through. So now negative 5x squared becomes positive 5x squared, positive 8x becomes negative 8x, and 4 becomes negative 4. Cool. 5, 8, and 4 won't divide by anything. So at this point, I need to do the whole slide and divide thing. Remember what I'm going to do is I'm going to take the 5 and I'm going to multiply it times the last term. So we'll rewrite this way. Remember that I am multiplying by 5. Okay, so it's negative 1. It's x squared. I like not having a coefficient in front of x squared minus 8x. And then subtract 20. Factors of 20. So I need to list all those factors. Okay, so it's a negative 1 times a positive 20, negative 2 times a positive 10. Remember, you can use your TI-83 if you want to for that. 20 won't divide by 3, but we'll divide by 4, negative 4 times 5. Okay, so there's just a few less factors here. That's kind of convenient. Same thing here. It'll be positive 1, negative 20, positive 2, negative 10, positive 4, negative 5. And you got to write all that out, or at least I do. Can't do that in my head. But what I'm looking for is what will add up to be a negative 8. All right, so 20 minus 1, 19. That's not it. 10 minus 2, positive 8. That's not it. 5 minus 4, 1. By the way, if you're clever, you're going to see that, well, it must be this one over here. Negative 10, positive 2 being negative 8. And that's what I'm looking for is that negative 8. So I can kind of go ahead and zone in on the correct one. Cool. So there's my factorization. It's going to be negative 1, okay, x times x plus 2 minus 10. Don't forget, hey, I multiplied by 5, so I divide by 5, okay? And when I do that, I've got to simplify that. Remember, I'm just going to get rid of this denominator by writing this as 5x plus 2. And then x minus 2. There it is factored. Once you practice it, you'll discover that it becomes a lot simpler. The more you do it, it's actually pretty easy. And by far the simplest way to factor. So let's look at a third example. This example says 12x squared plus 48x plus 45. Well, Well, the first thing I need to do is identify, is there a GCF? All right, so I need to think about those things that multiply to be 12. Well, 1 times 12, so if I check it, I know that 1 times 12 is 12, and 45 won't divide by 12. 48 would, but 45 won't, so I know it's not 12. Maybe I should try 2 times 6, okay? So will 12 divide by 6? Yes. Will 48 divide by 6? Yes. What about 45? Will 45 divide by 6? I don't believe so. So it's not 6. Left then with 3 times 4. And 12 I know divides by 4. 48 will divide by 4. And I believe 45 will not divide by 4. Because I get a decimal number, so it's not 4. So what about 3? Because 3 times 4 is 12. So will 12 and 48 and 45 divide by 3? Well, I know 12 divides by 3, and 48, if I divide it by 3, I get 16. And 45, if I divide it by 3, I get 15. So my GCF then here has to be 3. Because 12, 48, and 45 all will divide by 3. So that's the greatest common factor. It's x squared, x, and then no x. So there's no variable portion of that. So I can rewrite this as 3 times 4x squared plus 16x plus 15. So still got to factor 4x squared plus 16x plus 15. And I've got that pesky coefficient here on x squared, and I'll need to multiply it times 15 in order to factor. So let me rewrite it this way. Remember, I'm multiplying by 4. So I'm going to need that information a little bit later as I work this problem. And so it's 3 times x squared plus 16x, and then plus 4 times 15, which will be 60. Now remember, I'm looking for factors of 60 that will add two things that multiply to be 60, but will add to be 16. So let's think about some factors here. First of all, 1 times 60, or 2 times 30, or 3 times 20. We also know that 60 will divide by 4, so it's 4 times 15. And 60 also will divide by 5. It's 5 times 12, and then 6. Gosh, there's a lot of these, aren't there? 6 times 10. 7 won't divide 68. I'm not sure if 8 will divide 60 or not, so I'll check it right quick. I'm thinking no. No, it's 7.5. And there's 8 and 9 won't divide 60. And so that leaves me 10, which is here. So I've got all the factors, lots of factors to 60. Well, if I add these up, 60, and I've also got, don't forget, I've got the negative factors. Negative 1 times a negative 60 gives me a positive 60, but this center term is positive, so I don't have to worry about the negative sides at all. Just need to worry about the positives. So 60 plus 1, 61, 32, 23, if I add those two. 19, still don't have anything that adds up to 16. I've got 5 and 12. That adds up to 17. So, that's close, but it's not there. Look at this. 6 plus 10. When I add those two, I get 16. That's what I'm looking for. All right, so I found it. All right, so I want to write my factorization then. And it'll be x plus 6 times x plus 10. So far, that looks good. Now, the last thing I want to do, since I multiply by 4, I've got to divide that second term by 4 as well. Let me show you the place that I make a mistake every time in factoring, and if I'm not careful. I get down to this step and I forget, hey, the 6/4, that's a fraction, but it's not reduced. It has to be reduced. In fact, to make this work, we have to write our fractions as reduced fractions. I can divide 6 and 4 both by 2. So, and I'll rewrite that. If you can't remember how to reduce fractions, there are lots of ways to reduce them. TID3 will reduce a fraction for you. But hopefully you can see both 6 and 4 divide by 2. And so that reduces to be 3 over 2. And also 10 and 4 will both divide by 2, which is 5 over 2. I have to make those reductions or this won't work. You'll end up with an answer that is not a correct factorization. Well, let's finish it out. We don't want to have this 2 in the denominator, so we'll multiply 3 by 2, and we'll get 2x plus 3. Same thing here, 2x plus 5, and that'll give me what I started out with, just like I needed. And that is the complete factorization. 3 times 2x plus 3 times 2x plus 5. And it doesn't matter what order. You can put 2x plus 5 first and then 2x plus 3. But that's using that method of factoring, especially when we have a factorization where there is a coefficient on x squared, and it makes it a lot more complicated. It's a lot simpler way to factor those. And so using that slide and divide or slip and slide or whatever you want to call it method, you can factor most any factorable trinomial.